Excellent.
Welcome to the Metasploit team demo meeting. Appreciate y'all joining us today. It's October now, harvest time. We've got some good stuff to cover this week and a slew of demos, which is fantastic. And we've got Alan Foster here with us from the Scoundrels team, who's going to be taking us through the framework bits, which I appreciate. So let's hop on in. I'm going to hand the virtual mic over to Alan here, and who's going to take you through the Metasploit framework bits. Alan?
Awesome, thanks, Bruce. Cool. So in terms of new modules, there are a lot of new modules in the past 2 weeks. Firstly, community member Red0xFF has contributed a new module which targets Arctica proxy versions 4.3.0 and below by leveraging a SQL injection vulnerability in the API key parameter on the login page. And this ultimately leads to unauthenticated code execution as root. Our very own Shelby Pace has contributed a new module which achieves unauthenticated remote code execution against the CLI component in Jenkins versions v2.5.6 and below, and we'll have a demo of this later. Community member Pietro Eleve contributed a new command injection module for various NC TP-Link cameras. And community member Bcols contributed a new Vios module, which is capable of breaking out of restricted shell by using a vulnerability within the telnet command. And he pairs this with the ability to gain privilege escalation via command injection exploit. And this impacts all versions between 1.0.0 and 1.1.8. Our very own Brendan Waters has contributed a new module for local privilege escalation on Windows via the Spooler service, and we'll have more details and a demo of this later. And our very own Spencer McIntyre has added a new module for the new zero login exploit, and this module is a pretty big deal. So we'll have a sort of full walkthrough of this later, which will be awesome. And finally, Spencer McIntyre has also added a new module to unify SOC's proxy support and has additionally marked the previous modules as deprecated. So now I'm going to use the old modules. It'll actually tell you about the new unified modules, which is great. Our very own Grant Wilcox has added a new post module for enumerating installed software and version information on compromised targets, and we'll have a demo of this later. And community member Zane Cali team has contributed a new module for decrypting secure CRT session files, which includes details such as IPs, ports, usernames, and decrypted passwords. We'll have a demo of this later. And again, more modules. Community member Eric Winters contributed a new arbitrary PHP file upload module for Mara CMS, which can be used to achieve remote code execution. Community member Tim WR has contributed a new Safari exploit module, and we'll have a demo of this later. And community member Antoine has contributed improvements to an existing AnyConnect privilege escalation module, and we'll have a demo of this later. And our very own Brendan Waters has contributed a new module which relies on a regular user scheduling a job, which will be later run as a system. And we'll have a demo of this later. And community member Hootie has contributed a new auxiliary and post modules for Vios, which allows you to pull out usernames, passwords, Wi-Fi creds, host details, and a couple of more things. And finally, our very own Christophe De La Fronte has added a new module for dumping SAM hashes and LSA secrets. And this work is a port of Impacket's secrets dump utility script. And we'll see a demo of this functionality later as well. For enhancements and features, our very own Spencer McIntyre has made improvements to Meterpreter's get system command to support a new RPC SS variant of named pipe impersonation. We'll have a demo of this later. Spencer has also updated the zero login documentation to now detail how to use the new Windows secrets dump module to form a complete attack chain without relying on tools such as Impacket. And finally, community member Chris Long has updated Metasploit's Docker image to also include both Python and Impacket. So you can rely on modules now that rely on that functionality. And for bug fixes, Alan Foster has contributed a fix to the OpenFast importer, which was crashing previously on unexpected white space around port numbers. And finally, Adam Galloway has made fixes to any modules which relied on the HTTP client mixin, which was also being used in conjunction with the remote data service. And as always, for details on recent framework activity, you can check out the weekly Metasploit wrap-up blog posts at blog.rapid7.com. And we really appreciate anyone who's making Metasploit better via contributions to the project. So a big thank you. And for demos, first up is Brendan giving us a quick demo of the printer daemon exploit.
Hello. So this exploit came out a couple months ago. It was one that hit Twitter with just a splash. This was the one where somebody came out and said that this was exploitable using just a simple PowerShell command. That's not really the case, and I wrote about why that's the case in Attacker KB. So if anybody wants to check out the reasons why that doesn't exactly work the way they wanted it to, feel free to check that out. In this particular case, what winds up happening is the crux of this exploit is that it prints to a file. There's this case where you can put out a print job, and the print spooler runs this system. And so the print spooler will have total permissions to print this file to any location on Windows. Now, there are a couple of interesting places that it's very useful to print to. And if you want to go ahead and hit go on this, we'll talk about what's going on. So here you see I've got nothing up my sleeve. This is a Windows 1903, Windows 10 version 1903. I've got a regular old session on here as just a normal user. We're going to go ahead and queue up the exploit. And what this does is it prints a DLL, which is a little bit interesting. But we're going to print a DLL to Windows System 32, which we're normally not supposed to be able to write to. Now, this is kind of an interesting exploit because we're going to print to that location, and we're going to have to do some side work to actually get that DLL loaded and run. So here we go. We set up the payload, which is going to be the DLL that we write. You're going to have to make sure that the payload matches the host's architecture because we're injecting this into a service, basically. So it's very important for that to match. There's a check that'll dump you out. Now, in this case, I'm setting disable payload handler to false. This requires 2 reboots to get the callback. So normally this is set up as sort of an asynchronous exploit. Set up a listener in one, set up the exploit in the other. In this case, I'm going to reboot twice. That's why I set disable payload handler to false. So we get a payload handler, and I set my delay to 600, so about 10 minutes. So we've run this. You can see we've uploaded the exploit. We've gone ahead and created that printer. You should have seen just briefly there was a pop-up that said there was a printer in a disabled state. So there is stuff on the screen. Now I'm rebooting the machine. I've lost my original session. When we reboot, that cues the printer to take the virtual printer to actually print the document to the System32 folder. We're now going to have to reboot again because we have to restart the service to load that DLL. So we're going to go ahead and kick off a second. Well, let me log in. We'll reboot the Windows machine again. And while rebooting this, we're actually taking advantage of the spooler service twice because the spooler service is what wrote that DLL, but we wrote the DLL to a location that the spooler service is going to now consume that DLL and call us back as the print spooler service. Also, one of my dogs is saying hello, so sorry about that. Okay, so we're restarting now. And in theory, we should get that callback just any old minute now. There we go. And we get the callback after restarting the machine twice. The catch for this that's very important is if you kill this print spooler service, which has the DLL payload loaded, it will automatically restart. Effectively, this exploit creates a continual backdoor because there's almost no way to clean it up. So be very careful if you use this exploit, because it will take some serious work. You'll probably have to boot into safe mode and do some changes that way.
Print spooler vulns are super hot right now. I guess it was sort of the anniversary of Stuxnet, getting people on that topic. And Brendan, I know that we had a few conversations when this first came out about how practical exploitation really was. But remind me, I think this was exploited in the wild, at least in a limited fashion. Do you recall if that's accurate?
I cannot give you a citation for it, but certainly this was reported out there, and I think people at least ran with it after, I think Alex Ionescu,
Yeah.
I think, was the one that reported this, and I think it went public after that.
Yeah.
On the side of that, there are two things that this exploit might need if somebody is looking for to be a contributor. There's a slightly better way to do this using the fax service, which would only require one reboot. I didn't get a chance to do that in this particular case. And the second is there was a wonderful talk at Black Hat, I believe, where CVE 2021-337, the lucky CVE, got released, where there is a bypass to Microsoft's patch that could be added to this as well if somebody's looking for to contribute.
Neat.
Great. Now we have another demo on the Windows Orchestrator, I believe.
Yes. So the theme behind these two is have patience for your targets. The first one, you have to get the target to reboot twice, and this one, you actually don't know when the callback or when the payload will launch. If you want to go ahead and start it, there's a bug in an API call for Windows API for schedule work. It allows you to schedule a job as Windows system, but it doesn't do any authentication checks to see if you are system. So in this particular case, you can see, again, I've got a regular old session up on a Windows machine. This is also Windows 10 64-bit 1903. Go ahead and queue up the module. This is a relatively straightforward one. Give it a payload, give it a session. You can customize some other stuff around it. In this case, I'm leaving disable payload handler to true, so no handler will be created. We're not going to get the callback because I didn't want to sit here for 12 hours. So we've got session 5. Verbose true. Now you can see we found the target's vulnerable, and we upload our exploit, and we're uploading our payload, which is an exe. We're then going to call that schedule work API and schedule the job. You can see here that the time is not something we can determine, but we basically ask the scheduler, hey, this is a background task, schedule this to run a system at some point in the future. Thanks for that. If you want to hop to the very end, that last screen, there it is scheduled and it is entered into a registry location. And in that particular case, you can see it should say there at the very bottom underneath, payload scheduled for execution at like I think it was 1 a.m. Yep. Yeah, 1:22:27 a.m. So at that point, this will run as your payload will run a system and call you back.
Awesome, thanks. And finally, we have one more demo from yourself, which is to do with enhancements to the Cisco AnyConnect module.
This one I did not write. I landed it, and it is based on work from our very own Christoph. In this case, if you want to go ahead and go forward, this is the Cisco AnyConnect privilege escalation. Basically a second CVE came out for this, and one of our community members adapted the original exploit to work under both. You can decide which exploit you would like to use. By default, it uses the newer one, I believe, because it's supported across more platforms. So in this case, queue up the module. Also, exactly the same thing as before. I do believe that this is an earlier version of Windows 1803, or sorry, not 1803, 1802, something like that. So this one, you do need x86 payload. And we're going to set the CVE to use as the newer CVE. You can see you can use either of them. 34, 33 is the default. Okay. So we upload the DLL. Well, I believe the way that this works is that you tell the AnyConnect that it needs to update. You give it that DLL, you write to the location, and then it loads that DLL, and in this case gives us a call back. And you can see we're authority system. A lot less patience involved on this exploit. And here I ran it again as with the other CVE to show that this particular AnyConnect version can work on either of those CVEs.
Cool. Any questions on that?
Patch bypass, correct? The newer CVE?
I'm sorry, what was that?
Was the newer CVE a patch bypass for the older?
I do not know.
It's a completely new CVE.
Okay, cool.
Yeah,
Thank you.
I think it exploits the same binary, but it is a separate issue.
Cool, thank you.
Thanks, Brendan. Now we have a demo from Shelby Pace showing us the Safari and operator side effect exploit.
I'm ready whenever you are.
All right.
Yeah, so this module was written by Tim Wright, and the vulnerabilities that this module exploits, they're part of Pwn to Own 2020. And so what happens is that this module exploits 3 separate vulnerabilities, with the last being a heap overflow inside various versions of Safari. And as you can see here, you'll get a session, and you'll end up getting code execution outside of Safari Sandbox. And that will be as the user running the Safari process.
That's great. Any questions? Awesome. And finally, we have another demo from Shelby with the Jenkins CLI deserialization vulnerability.
Yeah, so you'll note that this one is actually quite an older vulnerability. This is one that I decided to work on as part of a larger research project into Java deserialization. So basically what happens is it exploits the CLI component in Jenkins, which allows you to basically do some scripting, do some updates, and it actually listens for remote connections. And what it does is it calls read object on data that is sent across the connection, which allows you to get code execution via sending a signed object over. And again, you'll get code execution as the user running the Jenkins process.
That's great. Any questions on that?
I just want to say that this was some really cool research that Shelby's doing into serialization, which is a really hot topic this year. And I'm really curious to see if some of the new chains that Shelby is working on might improve the evasion capabilities by not using public chains for Metasploit. That's some really neat stuff.
Sounds it. It's great.
Cool.
Awesome. And now we have Grant Wilcox demoing the new module for enumerating installed software.
Yeah, so this one's the enumerate software version. So as you can see, we basically just got a normal session right now. I'm just going to query for a little bit more information regarding the session. So you can see we're a normal user, we've got a normal privileges, and we're running on a Windows machine. There's nothing particularly special about the account. Notice that this is just for Windows though, if you do run it on a different system. So I'm just showing here that this is Windows Server, well, it's Windows Server 2019, but I will print it out as Windows 2016 later system. The thing to note here, which I didn't actually explain earlier, was that if you're running as a normal user on most of the Linux systems that we support with this module, you may not always get all of the software versions, unfortunately, because the Linux systems did require different package managers. Some of them do require root. In this instance, on Windows, you don't actually require the root privileges, so you can still enumerate the installed software as a normal user, but just keep in mind that when you're running it on systems like OS X, for example, you might require a higher level of privileges to enumerate the available software. So here we're just going to go ahead. You can see that this module just takes one option, which is the session that we want to run it on, and then it will save it into a loot file. So I'll just go ahead and open up the loot file here just to show you what it looks like. Now, the reason we don't actually print this out to the screen, for those who might be wondering, is because sometimes, although the example output here is very small, the reality is most systems will probably take up pages and pages of information. So you can see we've got several things here. So we got the description, so like the short name of what we have installed. We've also got stuff like when it was installed, which can be very helpful if you want to know, hey, you know, when is a particular piece of software last installed. Like you can kind of get to see the organization and how often they might have updated some software. You can also see what version it is down to minute details like what specific minor version they have installed, which can be helpful if you're trying to determine what exploits might be applicable to a given organization.
Great, good job, Grant. And Grant also has a demo for the secure CRT password decoder.
Yep, so this one was a module contributed by CN Cali team. It's basically, the way it works is that a third-party contributor known as Hypersign, he found out that the secure CRT, even on the latest version, still uses a set of encryption keys, which are now publicly known. They've been, I guess, exposed publicly in one of his write-ups. So this module will basically go ahead, and if you want to play the video, you can see that it will basically just go ahead and go, hey, is secure CRT installed? If so, then we will try and gather all of the saved session information, and we will use the public research from Hypersign along with the encryption keys to decrypt any of the passwords that are available in those session files. So I'm just going to show, as I was showing there, that I've just got a normal user, normal privileges. We're also just going to go ahead here and enter in the passphrase. Now, you do need the passphrase if you are going to try and decrypt the passwords. It is optional if you want to set up the software with it, but the software does tend to recommend that you set up a passphrase to encrypt the passwords. You can also see this is run in the latest version, so just to show you that this stuff is still applicable even if you're running the latest version of the software. It might be, sorry, it might have been a little bit hard to see, but the prompt did actually show that it was running the latest version. So we're just going to go ahead and start up the module here. So as mentioned before, you do need the passphrase if you're going to decrypt the passwords. If the software was somehow set up without one, you won't need this passphrase, but generally speaking, the software does encourage you to set one up, so you'll most likely require this in your tests. There's also an option here, which I just wanted to discuss briefly, known as session path. Now, this is applicable only if you have a non-installed version. So if you have a portable version of Secure CRT, you can have that option to essentially just tell it where to find the session files, because then they might not be in the normal location per se. So that just allows it to dynamically tell it, hey, this is where the session files are, and this is where I want you to pick up the session information from. So if you'll continue the video, we can see that it does dump out the available usernames, passwords, the protocol, the host name, and the file name. Now, there is currently a bug in the module, which we are in the process of fixing at the moment. So ignore the text at the bottom. That is a known bug that we are trying to fix. But as you can tell, the rest of it works fine. You can still get which file name it was, which protocol, the host, port, and all the other details you need to connect.
That's great. Does that also store that as loot, like your previous demo?
Yes, so that error occurs before that information is actually dumped to the loot file. We do have a PR up at the moment to fix the error that was shown there.
Sweet. Thanks, Grant.
Yes.
And now we have a demo from Spencer McIntyre showing us the new zero login exploit, which is very exciting.
All right, so this was an interesting vulnerability. So what it allows the attacker to do is reset the machine account password on an affected domain controller. Would you mind starting the video? Awesome, thank you. Okay, so our auxiliary module is going to provide a check method and the ability to clear or set the machine account password to blank, and also the ability to restore it. So this vulnerability, actually leveraging it, involves a bit of a workflow, which is what we're going to show. Starting out here with checking to see if the remote system is vulnerable. So the only things that we need to know is the net BIOS name, which we also have a Metasploit module to identify, and the remote IP address. So after checking that the system is vulnerable, we go ahead and we actually run the module. And so this leverages the vulnerability to reset the machine account password to that blank value that you see down there. That's always going to be the value of a blank password for the NTLM hash. So we're going to start to use the machine account name, which is the same as the net BIOS name, with that $ appended there at the very end. So watch that. So now, as we're going through here, now that we've reset the password, we're going to go ahead and use the machine account name and the password to psexec into the domain controller, which we can see here. So now we have code execution on the domain controller, and interpret takes us a second to become responsive. But at this point, we've compromised the Active Directory domain. That was in a matter of, what, about 30 seconds? But at this point, the Active Directory, the domain controller, may have loss of service because the machine account password doesn't match the Active Directory password. So now that we've got code execution on the domain, we want to go ahead and we want to restore it. So we're using the brand new secret stump module here. We're again authenticating as the machine account with that blank NTLM hash. And we're going to run grep, and we're going to grep from the machine account name. And so that's that the secret stump module, we're only getting out the original password that we can then go back to the zero logon module to restore. And so this is going to put the password back to how it was before we found it, to go ahead and restore that functionality so we don't have services on the domain controller that are going to act like they're broken or anything like that. If you're using this on an engagement, you probably don't want to leave it set to blank for any longer than is really necessary. So that's why we're restoring here, but we already have our code execution on the domain controller still. So that's the full workflow, all within Metasploit using the brand new secret stump module. So huge shout out to Christoph who helped out with that, and we're going to be doing a little bit more of an in-depth demo and announcement of that later on. But it is included in the last Metasploit release as of last week. So does anybody have any questions on that?
That's really cool.
Yeah, that's awesome, Mark. Good job, Spencer and Christoph.
Thank you.
Awesome. And finally, we have another demo from Spencer showing us Interpreter's get system capabilities being expanded into a fourth technique.
All right, so this isn't quite a new exploit module, but rather an improvement to the existing get system functionality, which we don't really see new techniques added to that very often. But this adds in a fourth technique, which is a variant on the named pipe impersonation that allows a user that is running as the network service. So if you're running as the network service user, you can leverage a flaw in LSASS that was identified by James Forshaw, that if you define an explicit path, LSASS will return the token to the first process, which will be the RPCSS process, which generally has an NT authority system token, and you can then open a handle to that process because of this LSASS behavior, and you can duplicate that token and copy it over to yourself, allowing you to escalate from network service to NT authority system, thus increasing your privileges. Thank you.
That's great. Thanks, Spencer.
Yeah, thank you, Spencer. That's awesome. And thanks everybody for all those demos. Those are fantastic. Great content. Leading into our last section of the demo, update on Attacker KB, the attacker knowledge base, where you can learn about and discuss which vulns matter and why. Just visit attackerkb.com. The team has been working on, continues to work on a bunch of cool stuff. And we have a demo today from our own Aaron Bleiweiss to show off some front-end performance improvements.
So we recently deployed several front-end optimizations to help Attacker KB load faster. This will be a quick high-level overview of both how much we improved and also what we changed. So we gauged our performance using a built-in performance audit that's included within Chrome DevTools called Lighthouse. And Lighthouse basically will run an audit against the site and give you a whole list of what can be improved and also give you a performance score. And this was our before score. We got a 6 out of 100. And one of the items in this metrics list is largest contentful paint, which is defined as measures when the largest content element in the viewport becomes visible. It can be used to determine when the main content of the page has finished rendering on the screen. So this is a metric that very directly impacts SEO, and in fact was something that was popping up in our Google Search Console as negatively affecting our search ranking. And just to give you a sneak preview, this is how we ended up after the changes. We got as high as a 91 on our performance scale, so huge improvement. I want to mention a couple things real quick. One is that these scores are for mobile. If you did the exact same test on desktop, the scores would be a little bit higher, but we tested on mobile because that's how the Google bot actually crawls the website. So mobile was our metric baseline. And then also wanted to mention that the time here in seconds next to largest contentful paint is probably a little bit inflated just because Lighthouse does a couple other extra tests when it's loading a page that your browser, your mobile phone probably wouldn't do. So while the numbers are inflated, you can still get a good comparison between the two looking at this. So yeah, here's an overview of some of the changes that were made. So first of all, we added compression to all of our static assets using Brotli, which is Google's compression library, and also gzip as a fallback for any clients that don't support that. So all of the assets are being served in a smaller file size overall. And we also are compressing the HTML responses with gzip as well. We've reduced the size of most images on the website, so you're not loading a big image that actually displays at like 200 pixels wide. And we're also requesting third-party assets, such as all of the GitHub avatars, using a query param, something like s equals 50, to actually request the image at a smaller size. We removed a lot of unused JavaScript libraries, such as Font Awesome, which we were really only using for a couple icons. We reduced the size of some of our other JavaScript imports as well. We consolidated a lot of code that was being shared across the website. So rather than loading it in multiple times in multiple different places, we consolidated it into some single shared files that can be cached and reused across the site. We added cache control headers with various TTLs for all of our static assets so that your browser can cache those assets, not have to re-download them every time. We added deferred JavaScript execution. Here's a quick little graph of before on the left and after on the right. Using the attribute defer when including the scripts in your web page makes it so that you're not blocking the DOM execution or HTML parsing, waiting for your scripts to execute. So that was a huge performance improvement just with one keyword addition. And we added some font optimizations as well, such as preloading key fonts and adding some attributes to prevent the infamous flash of invisible text, FOIT issue, which happens when your system has not yet downloaded the font and then flashes your text in afterwards after the font is downloaded. So this is a really high level overview, but just a list of some of the things that we changed. There's a couple other small tweaks that are more in the weeds. Each one of those also helped bump the score up a point or two. And wanted to mention also that all of the changes here were specifically focused on Webpack in the front end. None of this touched like optimizing the API or the database or any other stuff. This was just purely front end and mostly JavaScript Webpack stuff. So yeah, if you have any specific questions, feel free to ask me afterwards about what changed, but check out the site. Hopefully it's faster and you, all of our users have a better experience.
It is way faster. Yeah, I encourage everybody to go check it out. It's real responsive now when you load it up and click into stuff.
Wait, I'm gonna try it right now.
Do it.
Awesome.
You'll be if you're not money back guarantee if you're not impressed. It's good. It's really good stuff. Are there any other questions for Aaron?
Aaron, your graphics game is on point.
Thank you. That was really the main takeaway here.
Excellent.